very often in an application problem, you can learn a lot by interpreting the derivative of some function. We're going to answer the question, what does f prime mean in real-world terms? And to answer this question, first of all, we have to know what f means, right? So it's going to be a different answer for every different circumstance. Let's think about how to go about doing that. Our 0th interpretation of the derivative is a geometric one. So if we're doing geometry, this is perfectly fine for us, right? So f prime is a slope. That's the slope of the tangent line to the graph. Okay. If we're not doing geometry, if we're doing something else, then we better think differently. The general principle at work here is that when you want to understand a mathematical object, thinking about its units can be really helpful. Let's do that for the derivative. The derivative is this limit of quotients. The numerator says f minus f, so that's going to be the same units that f has. And what about the denominator? Well, a and c are input values, so that's a difference of input values. It'll have the same units as the input does. That means that the units of f prime are just the units of f divided by the input units. Let's do an example and see how that helps us understand what f prime means. This is from mechanics, right? That's the physics of motion. So if f represents our position, measured in meters, at time t, measured in seconds, each of these quotients has units meters per second. Well, meters per second is the way you measure velocity. And that gives you the hint. This is the average velocity from time A to time C. And now we're going to let A and C get really close together. So we're measuring average velocity over shorter and shorter periods. That's what we call instantaneous velocity when we take the limit. So what does f prime mean? Well, it's a velocity. All right, I want to go through several other examples, and it's not really essential to remember the details of each example. What I want you to see is what the process here is. So we did position as a function of time. The derivative of that is going to be instantaneous velocity. What if we measure the population as a function of time? Well, then the units of the quotient are going to be persons per year. What is that? That's an average growth rate, right? That's telling you how much the population is changing, each year. What if we take the limit and get f prime out? Well, that's going to be the instantaneous growth rate. So you notice that if you see the word average in this quotient, that turns into an instantaneous when you take the limit. Okay, let's say we buy widgets, right? We buy so many widgets, and it costs so many dollars. Then the units of the quotient are going to be dollars per widget. That sounds like a price. In fact, it's an average price. What happens when you take a limit? You get what's called the marginal price. We'll talk about that word marginal. How about labor costs, right? So you have some people, you're going to pay them to do so much work. That's going to cost you some money. Well, the units of the quotient are then dollars per man hour. That's the average labor cost. When you take a limit, you get the marginal labor cost. How about your paycheck? You work some number of hours, you get paid so many dollars. So the quotient is dollars per hour. You can use that to compute your average hourly wage. For most people, their hourly wage is constant. So these two notions, the quotient and the derivative itself after you take the limit, those will be the same. But if you imagine having like a signing bonus, then your average hourly wage and your hourly wage are going to be different. Here's an example from physiology. Let's say that I measure the heart rate in beats per minute of a subject to whom I'm administering some cocaine. More cocaine, faster heart rate. So the units of the quotient are going to be beats per minute per milligram. How do we interpret that? Well, there's not really a good word for the average version of this, but there's a great word for what happens when you take the limit. That is going to be your sensitivity to cocaine. All right, let's talk about these words, marginal and sensitivity. I introduced those. Maybe you haven't seen them before. Let's try to understand what they mean. If you ask someone in the medical field what sensitivity means, they'll say something like, it's the response per unit. So I say my skin is not very sensitive to sunlight. If I'm out in the sun for 15 minutes, my skin isn't going to be bothered by that. There are some people who are very sensitive to sunlight. So in that same amount of time, that same 15 minutes, their skin will change a lot. It'll have a strong response. So they are more sensitive than I am. If you ask an economist what marginal means, they sometimes use the phrase at the margin. They'll tell you something like, that's the contribution from the most recent input. Okay, let's see why both of these are a reasonable way to think about the derivative. Remember, the derivative is the limit of some quotients. And we can think of that quotient as being the change in output divided by the change in input, and then we're allowing the change in input that we care about to go to 0. Let's rewrite that limit as an approximation. Now, we're going to clear denominators. So what does f prime times delta x is approximately equal to delta f tell us? Delta f is the change in the output. Delta x is the change in the input. So one way to understand f prime is to say if you change the input by so much, you take that amount you changed, multiply by f prime, that should tell you approximately what the change in output is. That's sensitivity. That's the response per unit. Now, economists and people in finance often consider things that can't be broken up into smaller pieces. So if I'm buying widgets, it doesn't really make sense to buy half a widget, which means the smallest that delta x could possibly be is 1. So let's see what happens when delta x is 1. That means that the change in f is approximately equal to f prime. That's what marginal means. It means from the most recent 1, as you go from the current level to the current level plus 1 in the inputs, what happens to the output?